All right, in this second part of the videos for 3.1, I'm going to talk about the power rule, and the power rule is one of the most useful rules for calculating the derivatives using the shortcut, using these shortcut rules here. So the power rule is used to take the derivative of these power functions, that is, functions that are x to some number power. And you could go through the definition and show that this is true, but I'm just not going to go into that detail. We are just going to talk about the power rule and then show how to use it. So, okay. So here's the power rule. It says the derivative of the power function, right, x to some number power. You would pull the power down, so bring the original power down, and then subtract 1 from the power, and that will be the new power there. So that's it for the power rule. It's pretty straightforward. So let's take a look at a few examples and see how that would go. Okay, so here we have, in the first example, we have f of x equals x squared, right? So that fits the format of the power rule. It's x to some number power. So to take its derivative using the power rule, I'm just going to pull the old power down. So I'll have a 2 out in front. And then I will subtract 1 from the exponent. So 2 minus 1 is 1. So the derivative will be 2x to the first power. And we can just write that a little more simply as 2x. So the derivative of x squared is 2x. All right. In the next example, we've got f of x equals square root x, and we want to find the derivative. So when you first take a look at this function, it doesn't even look like a power function, right? Because it's a square root function. So what you're going to find in this class is that anytime you have one of these radical signs in here, it's almost always better to rewrite it as a fractional exponent. So doing that, right, is pretty straightforward. F of x equals x to the 1/2 power. So the square root of x is like raising x to the 1/2 power. So notice I didn't really do any calculus there. That's just algebra. I'm just rewriting this guy in a format that's a little friendlier to use. And so now that I've rewritten the function in that format, I can see that I've got x to some number power, and I know that I can use the power rule to take the derivative of that. So, okay, so how would I do that by the power rule? Well, I would pull the power down, so I have a 1/2 out in front, and then the new power, right, is going to be the old power minus 1. The power is going to drop by 1, so 1/2 minus 1. When I subtract that, 1/2 minus 1 will be minus 1/2. So the derivative will be 1/2 x to the minus 1/2. So on some of these problems, you're going to have to simplify. Especially later on, you're going to have to take the derivative and then simplify it. So it's a good idea to practice that here. So just remember what that negative power means, right? It basically means 1 over x to the 1/2, right? And then I have two fractions here, and I can multiply those things together, and I get 1 over 2x to the 1/2, right, for the derivative. So this answer here would be fine, although sometimes you're going to have to simplify things more. So you probably should go ahead and practice getting rid of the negative exponents in the derivatives like this, so you'll be ready when the time comes later. All right, the third and final power rule example that we'll do is f of x equals 1 over x squared. All right, and this function, 1 over x squared, right, is not in the format x to some number power, but it's also pretty easy to rewrite that in a format that's exactly like the power rule. So 1 over x squared, right, I can rewrite that as x to the minus 2 power. Here the x squared is on the bottom. I can move it across the fraction bar as long as I change the sign of the exponent. So 1 over x squared is exactly the same as x to the minus 2. Again, notice that that's just algebra that we're doing right there. There's no calculus involved. I'm just rewriting the function so I can directly use the power rule on it. And now this exactly matches the format of the power rule. It's x to some number power, whereas here it wasn't quite in the form that I needed it to be in order to use the power rule. So, Okay, so now the power rule says pull the old power down, so I'll have a -2 out in front, and then subtract 1 from the old power to get the new power. So -2 minus 1. And so simplifying, I get -2x to the -3 power. Okay, and so that answer is okay if you don't mind having negative exponents. But again, later on, we'll have to simplify these things and get rid of the negative exponents. So just go ahead and practice that. And so to get rid of the negative exponent, I would just bring that x to the -3 down again to the other side of the fraction bar. And in doing so, right, the power should be a +3 when it's written down on the bottom. So here is the answer completely simplified without negative exponents. And that's it for this part, and I will put a couple more parts and examples for chapter or section 3.1 up as well.